Hello everyone, today we are going to work on this character, this robot like character. I'm gonna create this character using a pawn blueprint, and we will be working on how to get the movement inputs and how to set up the character movement and which movement component we should use, because we are not using the usual character. And yeah, let's see how to implement this today. And this episode is sponsored by this generous patron. Thank you very much for the support. Okay, so this is the usual third-person project, and into this project I have imported this sphere robot animation blend space. So here we have this character with walking animations in forward to right to left, so basic animations, right? So I'm going to implement a character using this blend space and this character mesh. Okay, so first let's create a folder pp, and for this character I'm going to use, right, so I'm not going to use a character, I'm going to use a pawn, because we are going to make this character walk on the walls as well, right? Let's call it spider. Okay, and I'm gonna import, where's the mesh? I'm gonna use this mesh as the character mesh. Let's drag and drop here, and again, if you don't notice, just again drag and drop this SK sphere robot or this character mesh onto the default scene root, so it will become the scene root, right? Okay, and now let's add a spring arm component. Move it maybe like this, and let's attach a camera. Oh, there is offset. Let's make it 0. Right, now let's place this character in the map, and I think we have already processing this character. Yeah, so I'm gonna disable auto process player, so that when we start the game, this character will not be possessed by the player controller and we will not be controlling it. So I'm gonna use this character and auto process player. I'm gonna enable it for player 0. Let's place it here. Let's place it like this. Okay, now as you can see, this is what we get, right? Now let me open this third-person character, because I want to copy the camera inputs, mouse inputs for the camera. These are we can copy with the comment as well, right? Now when I play, oh no, If I enable use pawn control rotation, I think we have enabled it in the camera boom of the third person controller. Now we should be able to do look around like this. Okay, I think it would be more convenient if we have a spring arm length a little longer. Yeah, now we can see it clearly. Okay, so I'm gonna add a new event, cast trace surface. So this, I'm going to use this event to do a line trace and determine the surface. It could be either below the character, or it could be the sideways, because if the character is walking on a surface like this, it should be in the, it should be detect that wall. So because of that, I'm not going to use the name trace word trace flow. I'm going to use trace surface. Okay, so here let's do a line trace by channel, and as the trace channel, let's use camera channel. Start would be, first we need the get actor location. So we will be tracing downwards the character, actually whatever the character orientation. If the character is like this, the trace will be going down. If the character is like we can't rotate here. If the character is rotated to the left or to the right, if the character is rotated to the left, the line trace would be happening from here to this way, in sideways basically, right? So trace start location would be, we need to get up vector of the character, get actor up vector, right? So let's multiply this by 200, and let's add this to the actor location, and again let's subtract this from the actor location, so that we have, I'm going to use this one as the starting point and this one as the end point. Let's add the debug type of the line trace for a duration, and I don't think I have to call this function in every tick, so therefore let's use a timer. Set timer by event, create event, use in trace surface. Let's try 0.5, sorry 0.5 not 5, and this should be low fin. Right, now if I play the game, we can see this line trace downwards, and if I go here, if I select the spider as the debug object, you can see this trace surface is being called. Okay, now here, so using this we should be able to determine the actual location character should be. So ideally, if I look at this from left side or right side, this what's this amount? This is 1 meter. Okay, I guess then it's like 100 units above the surface point, right? Then here let's have a branch, and if there is no hit point, and let's break this. If this is true, that means we have a hit, so we can use this location as the hit point, and using that location we can calculate the actual location character should be in. So let's promote this to a variable. Let's call it hit surface location. If this is true, that's the surface location. If there is no hit, I'm going to use the, duplicate this. If there is no hit, that means false. As the surface location, I'm going to use this trace end. And now we can calculate the target location using the surface location. Get the surface location, and also get actor up vector, multiply this by 100 and add to this surface location. So this should be the target location that the character should be moved into. So let's promote this to a variable. Let's call it target location. Like this. Right, now we need to move the character to this target location, and I think we can do that here. So how? Let's get actor location, and also get the target location. Let's do a lerp. Oh wait, is this the best way? No. Yeah, let's add moment component. What kind of a moment component we can have? Let's use this floating point moment. Oh no, wait, let's try character moment. And when we are going on the walls, we can use the flying mode. It's not available. Yeah, right, it's only available for characters. So yeah, we have to use floating point moment. Okay, now in the event tick, let's add movement input to the direction. Let me collapse this. Oh wait, we don't have to do it. Okay, we can get that location and also we can get the target location. So from this we can get unit direction vector from the character to this target location, and that is the world direction. So scale value is 1. Yeah, right. Now let's see. Okay, now the character is there. Oh wait, why did it move there? Is that character is here? Let me simulate without playing. Alright, I think 100 is too much, so yeah, let's try 50. That's also too much. Yeah, actually this, we don't really have this surface location is the target location, because the root of the character is in the floor level. That means in this position. Okay, so this part is actually redundant, this part. So yeah, anyway, I'll use the target location like this. Now if I play, this is the character, but why does it move here? Okay, the reason to, I think the reason to move it here is because in the beginning by default the target location is 0 0 0. So in the beginning let's set target location to the actor location. So it shouldn't try to move to the 0 0 location. Right, now it stays here, and you can see this is kind of vibrating. Yeah, that's because we always have a movement input here. So scale value, we can change it like this. We can get the difference. From here to here, and from the difference we can get the vector length. So then we can actually have the distance between these two vectors. Actually I think we can use distance too. Yeah, we don't really have to do this. So based on the distance, let's derive this movement input. So let's divide this by, let's say, 100. Then only if we have distance larger than 100, we would have input larger than 1. So let's clamp this so that we wouldn't have a very high value for the movement input. Right, so now it's not vibrating. Okay, now we need to implement the movements with moment input. Right, now to add the moment input, so we already have this target location. So let's get move right. Yeah, we have this move right and move forward axis values, because we already have this axis set up, because we are using the third person template. So here we have move forward and move right. So I'm going to use them like this. From this one we get the move right and move forward values. So move forward means character want to move along the forward direction of the actor. So get actor forward vector and multiply it by this move forward value. Then let's add it to the target location. And let's use that as the when we calculate the world direction. Similarly here. And using the move right, we can get actor right vector multiplied by move right and add it to the target location. Right, now I should be able to move left and right. Yeah, it is moving, but it's very slow. See, so I think we can have some multiplier here. Let's write it. No. Okay, the reason is this timer length interval is too slow. That's why we get that snapping like effect. Okay, 10 is not enough. Try 50. Right, 50 seems good. We can move back and move forward. So for the move right as well, let's add the multiplier. See, now the character can move. But if I try to move here, oh, it can move there as well. Right, now the next thing is so here we are directly using the actor forward and actor right. Right, so here now let's try this character to orient towards the direction of the movement. Actually for character classes we have that option by default, but we don't have it here. But also we have this use controller rotation. If I do that, when I turn, the character is also turning, but that also I don't like. So I want the character to turn as I move. So get velocity and get rotation from x vector. So this gives the rotation corresponding to the direction in which the vector points. So let me split this, and here set actor rotation. We can actually, instead of directly setting it, let's lerp in shortest path. This is the target. This should be the current get actor rotation, the current rotation. Let's use 0.1, and I'm gonna only change the yaw. Why does it keep changing? Alright, we must always have a small velocity. That should be the reason. Okay, so then let's do this only if the velocity has a certain length, like vector length. If this is larger than, let's say, 10, so it shouldn't move. Oh, it does. Okay. Oh wait, did I keep this enabled? Alright, that should be the reason. Right. Oh, why it doesn't move? Alright, now that we are using this actor forward and actor right for the to calculate the movement directions, we can't actually use that if we are turning the character towards the movement. So we have to use the control forward and control right. So get control rotation, just like we have done in the third person character. From the control rotation, break the rotator, get only yaw. Actually we may not have to use that in here, because this character is going to use in all ways, not just in horizontally. Yeah, so get control rotation, and from that we can get forward vector and right vector. Use that instead. Right, now it is working, but we have a slight problem. You can see when I stop, it rotates. Right, let's remove this print. This is for the target location, and let's print the velocity, just to get an idea how much of a velocity we have. What's the speed? It's over 100. Okay, then let's make this 100. Yeah, now it doesn't rotate. Okay, and one more thing, in order to keep the character without submerging on the ground, what we can do is we can make sure the Z component is always this target location, always comes from the target location. So break this, split. X and Y can come from this calculation, but the Z always needs to be coming from the target location, then it wouldn't submerge. Let's check. Oh wait, what's happening? Sorry, wrong. This should be like this, and this one, this is where we need to do the calculation. X and Y is from here, Z is from the target location. Yeah, see, now it's not submerging. Okay, so now I want to align the character to the why does that happens? Okay, let's fix that later. So let's work on the animation. And for this alpha, what if we decrease this further? Why is that happening? I'm not sure. Right. So the animation. We don't have an animation blueprint, but we have this blend space. So let's create. Can we create animation blueprint from this? No. But we can create using this. Okay, create anim blueprint. Anim VP. No, PPA. Sphere bot. Let's call it spider. And put in the animation blueprint, put in the BP folder. Right, so as the main input, I'm gonna use this sidewalk run animation blend space. So we have to, yeah, let me rename these axis values. This is speed x, no, horizontal, no, side, forward, Okay, save it. Side and forward. Right, now we need to calculate this. Let me promote this to variables, side and forward. I'll call them speed side, speed forward. Now in the event graph, here we have target point owner. Let's first add is valid node, so that we wouldn't run into any null reference errors. If is valid, we can get velocity. Also we can get forward vector. Also we can get right vector as well. And if I multiply the velocity, if I do a dot product with a forward vector, we can get the forward component of the velocity. Same way, if I do a dot product with right vector, we can get the right component. Set speed side and set speed forward. This result is forward speed, this result is side speed. And let's use VPA spider. Right, let's see how it looks. I'm not sure how it looks. Sorry. Idle is here, and here the value is side is 400, forward is 0. Well, that's wrong. Not wrong, that's, I'm not sure how does that. Okay, so actually this is the forward of the character. Right, and side, I think it would be better if side is changing from minus value to a plus value. First we need to rotate the character, so let's, from the root, let's add some rotation. Here transform modify 1. Right, now want to modify, let's use root, and rotation should be applied at to existing in component space. Let's try 90. Right, No, it should be minus 90. Right, and let me print the speed x value and speed y value as well, speed forward and speed side, because I don't think this speed side matches the values we have here for each axis. Forward, then side. Let's remove this printing of a speed in the character blueprint. Okay, it changes from side minus to plus. Let's check it in the output log. See, 26, 49, 200. Okay, so then let's change this axis value of the side axis minimum to minus 400 and maximum to 400. Right, now let's see. Yeah, much better. Okay, and I'm gonna stop this episode right here. So in the next time, let's see how to make this character walk on walls and other non-horizontal surfaces. And as always, project files will be available for the download, but please note that I won't include this character mesh and the animations because they are from a asset in marketplace and I don't have the rights to share it. So but I will include all the character blueprints and the animation blueprint without animation, that maybe not the animation blueprint, all the character blueprint I have created.